Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I am Ankit Sir bringing you day 4 of our 60 out of 16 KCET math series in 100 days. Okay, what we have covered so far, we have done sessions on relations and functions, right? Where we learnt about types of relations, types of functions. Then we have done session 1 for our ITF, Inverse Trigonometric Function, where we discussed Inverse Trigonometric Function in detail for all the graphs. With the graphs we have done it, we have solved questions on them as well. Today's session is about some more questions we have taken in ITF and some extra properties that we're going to use. So we're going to use, like domain and range, how we're going to use, okay, and some other extra properties are also here. So we are going to solve all these questions today. So stick with me. Get your pen and paper out and solve all the questions here, bacha, okay? Solve all the questions here with me. Let's start with the session. So in the session first, I will recap all of things that we did in the previous class. Quickly we'll recall it and then we'll move on to the questions that we are going to do in this session. Okay, let's begin. So over here, this is the most important recollection for the previous session. We must know all the 6 ITF and their respective domains and range, right? So what is the domain? For sine inverse, cos inverse and tan inverse. The first 3 are sine inverse, cos inverse, tan inverse. So sine inverse is here, cos is here, tan inverse is here, right? Sine inverse domain, and this is what? -1 to 1, -1 to 1 and r. Remember what we did? We did what? We restricted a domain of sine function. If you recall how we plotted the graph, if I go forward and show you how we plotted these graphs, we defined it that all the ITFs are not defined because the trigonometric functions are many one functions, right? If you take their entire domain, then functions is repeating itself multiple times. They are periodic function, so we cannot define it as 1 1 on 2. Then how will we take it as invertible function, right? So what we did was we gave restrictions on the domain. And how can we do that? By making sure that range does not change. So by keeping the range same, we restricted the domain, right? And then we got these values, if you remember. So and then we had to do what? X to y. If the function was, if you remember this, if a function fx is defined like x to y, what is x? Set of all numbers which is part of domain, and y set of all numbers which is part of range. Okay, so x to y, then I'll have a function gx. If function fx is 1 1 on 2, then it can be written as gx is inverse of 1 1 on 2 function fx, which will be from where to where? Y to x. Means the range and domain will swap each other. Means the range will become domain and domain will become range. So that's why if you see here these values, this was what? Range, right? It became domain, and this was restricted domain of sin x, became range, right? Same thing for tan inverse, range, so domain and range. For cos inverse, domain and range. For cosec inverse also, what we have? This restriction, -1 to 1. -1 to 1 is not part of the domain. Over here also 0 is not part of the domain. Why 0 is not part of the domain, bacha? Because at 0 sine is what? Sine is 0, right? So cosec will be what? Cosec will be undefined, no? So for that reason 0 is not part of the range. Okay, sir. All right, sir. Means we cannot reach that point. Same goes here, pi by 2, and the domain for cot inverse is all real and the range is 0 to pi. So this is done in the detail. Please go and check the previous video if you are missing out on anything, if you are not able to link everything from this PPT, this slide. Okay, chaliye. Let's move on to the graphs quickly. We'll recall what are the graphs for all 6 functions I have drawn in detail, right? The graph for sine inverse of x looked like this, right? What was the nature of this graph? So increasing graph. This was, as I increase the x value, y was also increasing. So increasing graph. This was cos inverse, decreasing graph, sir. If I am going right from the left or the origin or any place in the domain, what is happening, sir? The cos inverse value is decreasing. One more thing I kept telling in the last class, that any inverse trigonometric function, what does it gives us? What is the outcome? Angles. So if you solve this function y equal to cos inverse x for any particular value of x, the value that comes out will be an angle. Whether it is a degree or radian is up to you which system you are choosing. But what is the result? It's the quantity is angle. Okay, sir. Tan inverse x was what? Again increasing function, right? If I am going from right, the y value is increasing. Okay, all right. This for cosec, it is decreasing function. Okay, this is again increasing function. This is again decreasing function. Again, I have discussed about nature of all these graphs, whether it is periodic or not, what is the minimum maximum value, all are discussed in detail in the previous session. Please go ahead and check it out. One more thing, I said for these graphs that minimum maximum doesn't exist because the value is not defined at minima and maxima, but we can find the limiting value of minima and maxima, right? Okay sir, this all was discussed beta, so go in the previous session and make sure that you have watched it and understood every single concept. Just recalling it so that we can use these concepts in the question that we're going to solve today. Okay, chaliye, moving on. Okay, what is next? Now we have some properties on ITF. So I have taken some equations here. First equation is what? Sin y equals to x. We can write this. Sin y equal to x, right? It's a trigonometric equation. Okay. What it means? It means sine of an angle y. Means y is what? Y is a value which represents, an angle. Y represents an angle. And x is some value which corresponds to that angle. Right, bacha? Okay. Now, I can write this equation 1 again in the inverse form like this. Correct? Means sine inverse of x. If x is equal to sine y, it means obviously sine inverse of x will be equal to y, right? The sine inverse is operated on x, so y is like that. Okay, provided what? It is 1 onto function. How we gonna get that, sir? Remember that restricted domain, keeping range same. I'm repeating it because very important. Okay, this should be in your mind. As ITF comes, this is the first thing that you should know. How is ITF defined? Restricted domain and range kept same. Okay. All right, it's like, like a long name of ITF. Remember those movies? I think there was a movie, there was a scene in some movie. I forgot the name of it. It was a Hindi movie. I watched it. I don't know if you watched it or not. So yeah, there was a movie where the very long name is there, right? So for that particular long name, even ITF, if the name is there, remember, add the two parts to the ITF name: restricted domain and range kept same. For what? For the respective trigonometric functions. Okay, sir. Which is defined as an angle of sine is x. Okay, means, okay, what is this? This is my angle. Okay, now if you are using this here for means sine y equal to x and y equal to sine inverse x, if I use y value here, bacha, means what is this? This is what? This is my sine of what? Y, no? Sine of y, right? So in place of y I can write what? I can write this, right, bacha? So in place of writing here y, I can write what? I can write sine inverse x. Why, sir? Because inverse is written like this. So sine inverse x is written like this. And what was the RHS? Equals to x. So from here we get what? Where we get, if we write the value of y from here, we get sine of sine inverse x equals to x. Sine of sine inverse x equals to x. What we do? What if we do ulta? What if we do ulta? How can we do ulta, sir? So this is the first part. This is the first. Sine of sine inverse of x is 1. Same thing I've written here. Ulta is this. Sine inverse of sine y will be equal to y. How can we do that, sir? So basically, in this thing equation, the equation is what? Y equal to sine inverse of x, right? Sine inverse of x, right? So x value is here, sine y, no? So what I can do is, I can choose to write x in terms of sine y. X in terms of sine y. So if I do that, bacha, what I get? Sine inverse of sine y. Same thing is y. So the two results that we have here, if we use equation 1 and 2, is these two results. Sine of sine inverse of x is x, y equals to sine inverse of sine y. Okay, now so basically there exists a pair which will make this kind of property happen. And what are those pair? For sine inverse it is sine x, for sine inverse it is sine, and for cos inverse it will be just cos, for tan inverse will be tan, and so on. Okay, for all the 6 ITF exist the corresponding trigonometric functions like sin x, cos x, tan x, cosec x, secant x, right, which will make this value or this property valid. But is it true all the time? Is it true all the time, sir? No, bacha, it's not true all the time. So where is it true, sir? Over here. Over here means for the x value, when x is between these limits, okay, means these values of x has to be defined, then only I can say then only this property will be valid. So sin inverse of sin x is x, cos inverse of cos x is x, tan inverse of tan x is x, cot inverse of cot x is x. This is true only if for sin inverse x, x belongs to minus pi by 2 to pi by 2. Okay, both inclusive. See here, equal to sign is present, bacha. Equal to sign is present here, means both minus pi by 2 and pi by 2 is inclusive. Over here you check, there is no equal to sign. Is there? Only less than. Okay, only less than sign is there. It means what, bacha? It is not equal to, means minus pi by 2 is not inclusive. Same way pi by 2 is also not inclusive. Over here again 0 to pi for cos inverse of cos x, cos inverse of cos x, and over here for cot inverse of cos x, again 0 to pi, but not inclusive of 0 and pi. I hope this is clear. Sec inverse x will be from 0 to pi, but pi by 2 is out. Why? Not defined, right? Because cos pi by 2 is what? Cos pi by 2 is 0, so sec will be not defined. Same way sec inverse is not defined. So we can't take it like this. Okay, chaliye sir. Okay sir. Okay sir. But you might ask, sir, isn't the x is domain, the domain part? Yes. So isn't the domain of sine inverse functions? Sir, you're confusing me. Sine inverse function domain is minus 1 to 1. Sir, you said that what comes out like of the sine inverse functions or inverse trigonometric function are angles. But you're taking what is going in the domain as angles. How is that true? So you check it out here, bacha. I'm not talking about sine inverse x, I'm talking about sine x, na? I'm talking about sine, because x is going where? X is going for sine. Check here, x is an angle, because it is, what is operating on x? The sine is operating, so sine will operate. Any trigonometric function will operate on what? It will operate on angles, right? So for that reason, obviously x is angle. So everywhere x is what? Is angle, because we have the operations as trigonometric functions, no? So x is being operated by these trigonometric functions, so obviously they will be angles. So that's why the restrictions are not on sine inverse. Sorry, this restriction of pi by 2 is not on sec inverse, it is whether on sec x. Why, sir? Because cos pi by 2 is 0, so sec pi by 2 will be undefined. That's why pi by 2 is not part of the domain. That's why pi by 2 is not part of the domain. I hope you can understand that. Okay, same goes with cosec also, because sine 0 is 0, so cosec is not defined. That's why when writing this domain for cosec x, we have taken out 0. Not a very big deal, but since what happens is not every time we have everything in our mind, right? So when you're watching this video, this might not make sense to you. Okay, you might think, okay, this is not that important, because in the question, sir, we only need this much. If we know this, we can solve it. But no, this is important, bacha. Because think about it, in examination, no, will they give very simple questions? Very simple, very, very simple. No, they will try to trick you, right? So if this is not given and you remember only this part, then you might have a chance to lose marks. So always remember, the key definition should be with you. Okay, so 0 is not part of the domain of what? For cosec inverse x? No, sir, only for this part, because x is the angle being operated by cosec, which is a trigonometric function. I hope this is clear. I hope this is clear. Okay, now we have few more, bacha. We have few more. Okay. And we will be using some formulas also in solving these questions. Okay, so whenever I'm using any additional formula, I'll write it in that question only. But we have few more important properties, and you will agree with me. Sine inverse of minus x minus sine inverse of x, cos inverse of what, bacha? Minus x, pi minus x. Okay. Pi minus cos inverse of x. Okay, now what is next, bacha? Tan inverse. These three are very important to knowing. Okay, means we must know these values. So this will be minus x. Okay, now this is the formulas. Is that all? No, sir, we must write. You only said right now, sir, knowing the domain is important, right? So for this, I will have to be from where to where? This will be minus. So again, the domains, the respective domains of these, respective domains of these. Okay, so what was this? Minus 1 to 1, right? The domain. Okay, the domain of cos inverse x is what? Again, same thing, minus 1 to 1. What is this? All real. Minus 1 to 1, all real, and minus 1 to 1. Okay, chaliye, moving on. So you remember this, we will use these properties, we'll use these values. Okay, all right. Now questions. I said no, I have covered most of the things in the first session, because in ITF now what is important is knowing the graphs, okay, understanding the domain and range. Rest will all applications. So we'll do more questions. That's why I could have just ended the session at first only, given these informations there, but I came up with 10 more questions for you, so that because what we need in ITF is more and more practice. And again, we'll have a mock session on this as well. So practice is the most important part in the ITF. That's why I have taken 10 additional questions, starting from this particular question, which I think you must have solved right now while looking at it. Very simple. What is the answer? Pi by 3. Why, sir? Pi by 3. What is the angle here, bacha? Theta. Where is theta existing? Theta is between this value, no, sir? Okay. If this is true, I just wrote this formula. Sine inverse of sine x is equal to x when theta belongs to, or if it is theta there, I can write it as theta only. Theta. Okay. So if theta belongs to minus pi by 2 to pi by 2, I can write this directly as theta, which is nothing but pi by 3. Answer is A. Let's move on. I hope this is clear. Simplest question ever. Okay. What about this? So this will not be directly solved. Let's simplify it forward. Tan inverse of tan 3 pi by 4. This is the question, right? Tan inverse of tan 3 pi by 4. Can we do something about the angle there? I can write this as bacha, I think. Tan of what? Tan of what? Pi minus pi by 4. Can I write like this? Check. Please check. So what I've done here is, I'll explain it to you. I've written this angle again in this form. I've written this angle 3 pi by 4 again in this form. I can write 4, if I subtract it, it will become 4 pi minus pi by 4, correct, na? 4 pi minus pi by 4 will be 3 pi by 4 only, no? So this same thing is written over here in different format. Now if you remember, what is this? Tan pi minus theta is just what? Check. Tan pi by 4. Which quadrant is this angle in? Pi minus theta. This is second quadrant, sir. Second quadrant, tan is positive or negative? Negative, sir. So I will have a negative sign here. I'll have a negative sign here. Correct? Correct. No? Pi minus, this formula I'm using, bacha. Tan of, this you have learnt, I think, in 10th also. Not 10th. For ICC people must have learnt in 10th, but others I think in 11th you must have learnt. Tan pi minus theta is what? Minus tan theta. What is it? Minus tan theta. Okay. Okay, sir. Minus tan theta is there. So I wrote here minus tan theta. Now what is this? Tan inverse of. Sir, you said the formula was, you only said right now, sir, tan inverse of x, sorry, minus x. But I can take x as tan pi by 4 now, bacha. Because if you solve tan pi by 4, I will get a value only, no? Tan pi by 4 will be a value, right? What is that value? 1. It is 1. So this will become nothing but tan inverse of minus 1. What did I teach you? Tan inverse of minus x is what? Just minus x. Okay? Sorry, just tan inverse of x. That's what I taught, right? Okay. Coming here. Okay. A mistake. Please forgive me. A mistake. Please forgive me. I wrote it as, this is the correct answer. Tan inverse of minus x is minus tan inverse of x, not x. Okay, my mistake. I made a mistake. So just please make this change. Okay. So if I have to continue from here, what I get? This will be nothing but minus tan inverse of 1, right? And this will be minus pi by 4, which is nothing but my option B. Check here. Minus pi by 4 is my option B. Okay. All right. Moving on to question number 3. Cos inverse of cos 7 pi by x. Cos inverse of cos 7 pi by x. Okay. Kar lenge. Again, the inverse and the trigonometric functions are in pairs, so not a problem, right? So how can we go about this, sir? I can write this as cos inverse of cos 7 pi by x. Simple. Very simple. Now cos inverse of, I can write like this, what? Okay, what about this? Pi plus pi by 6 will work. Check please. 6 pi plus pi 7 pi by 6 it will work na. If I am, what I am doing again here bacha, I am rewriting the angle only, nothing else is changed, just this angle is written in this format. Okay, pi plus pi by 6 will be what? How can I write this part? Just let me see, some people will have this confusion also. So 6 pi plus pi by 6, how much is that? 7 pi by 6, same thing is written here. Okay, rewritten that format. Okay, I hope you can understand that part. I don't need, so I'm erasing this thing. Okay, pi plus pi by 6, that is clear, sir, that much is okay, simple for us. Okay, what is cos pi plus pi by 6? Again, which quadrant? Third quadrant, right? So cos inverse of what? Minus cos pi by 6. I hope you know this. Third quadrant, cos is negative, right? Why third quadrant? Because angle pi means 180 degree. So pi plus any angle will be what in third quadrant, no? So third quadrant, cos is negative, so minus cos pi by 6. What is cos of minus x? Basically, I can write this as pi minus what? This value. Pi minus this value, what is it? One more step, then we'll write. So this will be cos inverse. So what is cos pi by 6? Pi by 6 is going to be minus, right? Pi by 6 is 30 degrees, so which is root 3 by 2. Now cos inverse of this, cos inverse of minus x will be pi minus cos inverse of x. Same formula here. What is this? Remember, cos inverse of minus x will be pi minus cos inverse of x. Cos inverse of x, please check. Pi minus cos inverse of x. Okay, so using this here, what I'm going to get? Pi minus cos inverse of root 3 by 2 is how much, bacha? Is going to be pi by 6 only. Pi by 6 only, correct? Now if I simplify, this will become what? 6 pi minus pi. So 5 pi by 6. 5 pi by 6. 5 pi by 6. I hope you can understand that. Cos pi by 6 was root 3 by 2. So same way cos inverse of root 3 by 2 is pi by 6. Subtracted 6 pi minus pi will be 5 pi. 5 pi minus by 6 is the answer. Answer is A. Simple enough. Okay, sir. Chali. So look, the session is all about questions only today. As I said, additional concepts or additional formula, whichever is there, I will write it the way I am writing here. I'll write it down here and we will keep solving the problems. Okay, let's continue, sir. Okay, sir. Okay, this question, what is the question? Let's read it. Sec square of tan inverse of 2. What is this value? Some angle. This is some angle. So yes, true, na? I can write this angle to be theta. So sec square of theta. Okay, same way cosec square of some other angle, not theta, let's call it as alpha. I don't know what angle is it, I don't know it, it's okay, but cot inverse will be coming as some angle only, no? So cosec square of alpha. Whenever I have square value, what is that we have learned? We have learned some trigonometric identities. And how does it look like? Sir, it looks like this, no? We have learned these two formulas for what do we have here? Sir, sec square and cosec square. So for sec square, what we have learned, bacha, is this sec square of theta is equal to 1 plus tan square of theta. Yes, sir, this we have learned, no problem here. Same way, cosec square of theta is equal to 1 plus cot square of theta. 1 plus cot square of theta. Now we will apply this identity in the question given. So how they have given it? Have they given it as theta? They have not given it as theta. They have given it as theta value is nothing but tan inverse of 2 and cot inverse of 3. So let's apply that. Okay. So I will get this as 1 plus tan square. Okay, let me write the question also so that there is no gap between the problem. Okay, I'll write the question also. The question was sec square tan inverse of 2, sec square tan inverse of 2 plus cosec square cot inverse of 3. Cosec square cot inverse of 3. That's the question. That's the question. I hope you can see that. It's 3. Okay. I'll try to write on this side. So I can rewrite this statement over here. Over here, sec square theta will be, this is my what, bacha? I hope you can see this. This part is my theta and this part is my alpha. It's okay. Same thing. I can write here as alpha also. No problem. Any angle can be written. Okay, theta or alpha, whatever you want to write. Sec square of theta can be written as 1 plus tan square of theta. So 1 plus tan square of what? Tan inverse of 2. Of tan inverse of 2. Tan inverse of not 12. It's just 2. Looks like that. I will rewrite it. Tan inverse of 2. Okay, sir. Now for cosec, what we'll have? Same way, sir. 1 plus cot square. 1 plus cot square. What? Cot inverse of 3. So cot inverse of 3. This is okay. Okay. 1 plus cot square. Now add 1 plus 1 will be what? This 1 plus 1 will be 2. Okay. Now let's check this out. I can write the whole square as like this, na bacha. Tan of tan inverse of 2, the whole square. Any problem over here? Any problem over here? Plus this one I've already taken here. I can write this also as cot of cot inverse of 3, the whole square. So the square is on the cot, right? So I can take the whole square to the entire term, okay, like this. Okay. Now moving on. 2 plus, what is tan of tan inverse of 2? Just 2. We learnt in the first slide only, sine of sine inverse is also x and sine inverse of sine is also x. Both is true. Okay, both conditions we learned, no? Check if you want to see if you are missing that part out. I will write it. I will show you here. See. So sine of sine inverse of x will give me x, and sine, if I am taking sine first, even that will give me the same result, or sine inverse first give me the same result. Okay, same result. So if we have to see here, okay, so this will be give me what? 2. And what is this? Under whole square. This is again 3. What is this? Under whole square. Answer is 2 plus 2 square is 4, 3 square is 9. 9 plus 4 is 13 plus 2 is 15. So my answer is what? The question that I took is coming as 15. Option D, 15 is correct. 15 is correct. 15 is correct. Okay, sir. Okay, sir. Moving on. Question number 5. Okay. All right. All right. So what is the question given? Sine inverse of cos 33 pi by 5. Sir, looks difficult. Looks difficult, sir. Let's write the question. Sine inverse of cos 33 pi by 5. Okay. Sine inverse of cos 33 pi by 5. Okay. That's the question. Yes, that's the question. Okay. Means we have to solve or simplify this part, then the sine will work, because sine will not work on cos. Sine inverse of sine has to be there. So somehow I have to get in terms of sine only. Let's check it out. Let us check it out, sir. Okay. The options are given here. We'll use it later, but right now let's solve the question. Let's solve the question. So what we have learned, somehow we have to rewrite the angle. Rewrite the angle. What does you? So how we are rewriting the angle? So either write in terms of pi by 2 or 2 pi. Why, sir? Why pi by 2? Because sir, at pi by 2, know what happens? Cos becomes sine, sine becomes cos, tan and cot and tan, and cosec and sec. Why? Because these are complementary functions we have learnt, right? At pi, sir, at pi what happens is angles, the ratios remain same, and we can see the angle from the quadrant rule, where which quadrant the ratios are positive. Okay, sir. Why 2 pi? Because 2 pi, the functions are periodic, like, you know, for sine and cos, 2 pi is a periodic number, means after 2 pi the value keeps repeating itself. Okay, sir. So that's why I'm asking you to check at pi by 2, or means the transform the angle at pi by 2 or pi or 2 pi. Okay, whichever suits in that particular question, no restriction at all. Okay, so in this question you can see I have a big value. 33 pi by 5 will be bigger than 6 pi, right? Because if it was 30 pi by 5, it will be 6 pi, no? 30 pi by 5 is written like this. 30 pi by 5, it will be what? 6 pi. So it is 33 pi by 5. So it will be bigger than 6 pi. Bigger than 6 pi. Okay, sir. Okay, let's see how will the angle look like. So I'll show you the angle first here, then I'll simplify. So I can write 33 pi by 5 as 6 pi plus 3 pi by 5. How, sir? Because if I simplify this, what I'm gonna get? 30 pi plus 3 pi by 5. That's the same thing, right? So now check this out. Now check this out. Now this step is not part of your answer, just explained you to how to check the angle. Okay, let's continue with the answer from here. So this will be what? Sine inverse of cos of what, bacha? 6 pi plus 3 pi by 5, right? But you said, sir, 2 pi, take it as 2 pi. But I can take multiples of 2 pi also, no? So if I have to write this is again a formula. I hope you remember. If not, then please remember from here onwards. Cos 2n pi plus theta is what, bacha? Cos theta only, no? Why, sir? I said this. The function is periodic at 2 pi. N can be any integral value. Okay, for that it will be periodic. Okay, sir. Moving on again. This is again what? Only a concept. Just not part of the solution. Okay. This next step will look like this. Sine inverse of cos 3 pi by 5. 3 pi by 5. Now is the challenge. So how to rewrite this angle in terms of what? Something sine has to come. Okay, first thing is how to write this angle so that it is solvable. So how can we solve this part? Only if there is a sine here. How can we get cos to sine? By using pi by 2. Let's try. How can we use pi by 2? So again what will happen? We have to transform the angle only, right? So what is my angle? 3 pi by 5. How can we use pi by 2 to get 3 pi by 5? Think. Is it more than pi by 2 the angle? Pi by 5 is going to be what? 3 pi is nothing but 540 degrees, right? So yes, it is more than pi by 2, correct? No? So pi is 180 degrees, into 3 will be 540 degree, by 5 will be more than 100, and pi by 2 is 90. So obviously greater than 90. Means I have to add something to pi by 2. Think again. 3 pi by 5 is more than 90. How can we say that, sir? Pi is 180 degree, pi into 3 will be 540 degrees, by 5 will be more than 100 degrees. So means I have to add something to pi by 2. Now what? Check. If I add pi by 10, check here. If I add pi by 10, what will happen over here? The LCM will remain as 10. 2 into 5 will become 5 pi plus pi. Answer is 6 pi by 10, nothing but 3 pi by 5. Same thing, no? So means I can rewrite this angle in this form. Why I don't have to write this, okay? In the solution, you don't have to write this. I'm explaining this because some students, and not some, lot of students, miss this part, okay? My goal here is to explain you that part. Look, if you're coming here, I kept saying this, if you're coming here, it means you are doing your work at home, you are studying somewhere, but you still have some doubts, right? If I don't clear these things, for some people it might, feel lengthy, sir, why are you explaining this part? But for those people who need this help, then it becomes very, very easy. So that's why, look, what is there in inverse trigonometric function? Angles, graph domains. So graph domains we have already understood. What is left? Angles. So that's why I'm giving emphasis on this part. We don't need what? All this. Okay, not part of the solution. Right next to this step, we can write what? Like this. Sine inverse of, what I'll write? Cos will become what? This will become pi by 2 plus pi by 10. Pi by 2 plus pi by 10, right? Now I can transform this. Cos at pi by 2 will become sine, sir. Which quadrant is this in, bacha? Which quadrant is this in? Pi by 2 plus pi by 10. Second quadrant, pi by 2 is 90 degrees, so after that will be second quadrant. Second quadrant, cos is negative, so minus sine pi by 10, sir. Sine inverse of minus x is what? We have learnt minus sine inverse of x. Minus sine inverse of x. What is the answer? Sine inverse of sine pi by 10. Answer is simply minus, and this part will become pi by 10. Answer is minus pi by 10. Check your answer, please. D minus pi by 10. Answer is minus pi by 10. I hope this is clear. Please check. Okay, very simple question. I've taken a little bit longer, but I hope you understood every single bit of it. Okay, let's move on to the next problem. Okay, now this value we have to find out for this given expression. Okay, for this given expression, again inverse trigonometric expression, we have to find out the values. Let's try it out. Let's figure it out. How can we solve it? Okay, how can we solve it? We'll solve it here only. We'll solve it here only. Let me write the question for you first. What is the question? 2 times of sec inverse of 2 plus sine inverse of 1 by 2. So obviously we need angles. We need angles part here. Okay. So I can rewrite this 2 as, so this sec inverse of 2 as one more thing is there. I have sec inverse. It means I need what in the bracket? Sec only. So sec will be 2 when? Sec will be 2 when cos is 1 by 2. Correct, na? Sec will be 2 when cos is 1 by 2. When is cos 1 by 2, sir? Sir, at pi by 6. At pi by 6. See, pi by 6 is 30. Cos 30 is 1 by 2. So sec 30 is 2. So I can write this as sec 30. 30 is, I just said, pi by 6. 30 is pi by 6. Again, I am explaining you how you can think. You know, how to process the question in your mind. Okay, being a student, how can we think, sir? Like this. Sec inverse of sec pi by 6. I can write this step and move on, but no. How will we proceed? From 2, we need sec inverse. We need sec. To solve for sec, I need cos. So, where is this? Like that, we can analyze and go ahead, picture. Now, sine inverse part. Sine inverse of 1 by 2 will be what? When is, I need sine only, that much is clear. When is sine 1 by 2? Sir, at pi by, at, okay, one mistake. Angle, sir, it is not pi by 6. It's pi by 3 now. It's pi by 3. Forgive me. So cos is 1 by 2 at 60 degree, not 30 degree. So it will be pi by 3, not pi by 6. Okay. I sometimes miss the table. Okay, not remember everything at once. So please forgive me if I'm making any mistake. If I'm making any mistakes, if you feel that, please comment below. Okay, I am also human. I might miss something out at times. So help me to evolve and create something really good for you. Okay, chaliye. I'll try to minimize my mistakes, okay, so that it is actually very useful to you. But still, I might make some, so help me out there. So sine inverse of 1 by 2. So sine will be 1 by 2 when it is 30 degrees or pi by 6. So it will be sine pi by 6, sir. Sine pi by 6, sir. Okay, we can simplify now, bacha, clearly. Why? Because these are all first quadrant angles. In first quadrant angles, everything is positive. So sec inverse of sec will become just pi by 3, bacha. This will be plus sine inverse of this will become pi by 6. Okay, please multiply this. 2 pi by 3 plus pi by 6. LCM will be 6, right? So 3 times 2, so 4 pi plus pi. Answer will be 5 pi by 6. 5 pi by 6 is correct answer. 5 pi by 6. 5 pi by 6. 5 pi by 6. Okay. So this, please make this change. Pi by 3 and pi by 6. Moving on. Okay. Seventh. Okay. Okay. Now this has series of trigonometric and inverse trigonometric functions. Okay. First is sine inverse here operating on this big bracket, which is again operating on this bracket, operating on this bracket. So I will start from where? From the domain part. What is domain? Minus root 3 by 2 for this question. Okay. So I will start from there. Okay. Let's see, sir. Now sine inverse of minus root 3 by 2. Basically sine inverse of minus x is what? It is minus sine inverse of x. We learnt it. Sine inverse of minus x is how much? Minus sine inverse of x. So sine inverse of minus x will become what? So I can rewrite the statement. I'll write the first two same. Sine inverse, this is same. Again in the bracket cos, this will same. Again this will become what? This will become what? Sine inverse of this was there. It becomes minus sine inverse of root 3 by 2. I hope you can see this. Is it visible? Not that greatly visible. Let me erase and rewrite it, bacha. Okay, let me erase and rewrite it. Okay. So first I will write sine inverse. So sine inverse, then cos will be like this only. So cos, okay, and then this part, this will become minus sine inverse of root 3 by 2. First bracket, second bracket, and third bracket. Okay, I hope this is clear now. Visible? Visible? 3 is not visible, sir. 3 is not visible, sir. 3 is not visible, sir. This is 3 here, okay? Given in the question, nothing I am doing. This is given in the question. Root 3 by 2 is given in the question, okay? So this rule we have already used. Let's erase this for now. Okay. Now, moving on. How can you simplify this? Sine inverse of cos. So this part will remain same. We can write this as sine inverse of cos, and this will become what? This will become what? Root 3 by 2 is when sine is pi by 3. So I can write this as minus pi by 3. This is nothing but minus pi by 3 because this is sine pi by 3. Sine inverse of sine will be pi by 3. So minus pi by 3 because this minus sign is there. This minus sign is there. Okay. Now cos inverse of minus pi by 3. What is it? Cos inverse of minus pi by 3 is what, bacha? Again a new concept. Cos of minus theta is what? Remember, just cos theta. Why, sir? Fourth quadrant. Fourth quadrant, what happens? Cos and sec are positive. Cos and sec are positive. So cos of minus pi by 3 can be rewritten as, so I'll write this again, sine inverse as it is. This will become what? Just minus pi by 3, right? So cos pi by 3, which will be what? 1 by 2. Which will be what? 1 by 2. Which will be what? 1 by 2. So again we have solved this. Now sine inverse of 1 by 2 will be what? Simply pi by 6. Simply pi by 6. So answer is what, bacha? B pi by 6. B pi by 6. Understood? So first we solve using which rule? This one. Sine inverse of minus x is minus sine inverse x. Okay. Then we use this rule. Cos of minus theta is cos of minus theta is cos theta, using the quadrant for the angles. Okay. And then we get it as sine inverse of 1 by 2. Answer is pi by 6, which is B. Let's move on, sir. Okay. Question number 8. Find the domain and range of. Find the domain and range of. The function is given here. Tan inverse is operating on log, which is operating on a quadratic function. I'll repeat. Tan inverse is operating on log, which is operating on a quadratic function with the base 4 by 5. What's the meaning of this? Log with the base 4 by 5. Let's get this part clear. Means if I'm writing like this, log x, let's say, to the base 4 by 5, for this function, what is the base value? The a value is 4 by 5, which is less than 1. So the graph will be like this, no? Graph of log will be decreasing function, right? It will be inverted like this. Means if I increase x value, what will happen to y? Y will be decreasing. Basically, if x1 is more than x2, then log of x1 will be less than log of x2 because it is inverse. Okay, it is inverted. The graph you can see is like this. Okay, decreasing function, basically decreasing function. If x1 is greater than x2, log will be less than the two respective values. Okay, all right. Again, if it is less than, this will be greater than. I hope you can understand. Okay, we'll see that. I just wanted to analyze the question. Okay, moving from here. So far the value or the base on which log is operating is less than 1. So graph is like this. This much is clear. Okay, sir. All right. Now we'll solve this part. The 5x square minus 8x plus 4. Let's see. So one thing which is very, very sure, we need to find domain and range, right? We need to find domain and range, right? So if you see here, so domain will be what? This value only, no? Where this is operating, which is where this is operating. Okay, sir. Where this is operating only for log, then what is this approaching on? So we have to figure it out everything. Chaliye, let's see. So the question is what? Help me write the question, please. So the question is, sir, tan inverse of log with the base 4 by 5, 5x 5x square minus 8x plus 4. Minus 8x plus 4, first bracket, second bracket. Okay, this is clear. Okay, okay. And this is given as fx. This is given as fx. No problems. No problem. Okay, let's take this part. 5x square minus 8x plus 4 as a function px. I can take this as function px. Okay, no problem. How will I find the nature of this? If I have to take like this, I take 5 common. I'll get x square minus 8x by 5 plus 4 by 5. Same thing, same px I am representing like this. So I can make this perfect square as x the whole square. Why making perfect square? It will make sense. It will make sense, and I'll relate with this graph. Okay, just let me continue for a second. Okay, now this can be written as, if I have to make perfect square, I can make it as a plus b the whole square or a minus b the whole square. I can see minus sign is there, means it will become a minus b the whole square. What's the formula? A square b square minus 2ab. So a square is there. What about b square and minus 2ab? So we'll figure it out our minus 2ab, then we'll go to our b. So what is minus 2ab? So minus 2 times of a is known, so x. Now what will I multiply to this part so that I get 8x by 5? Check. Because I am trying to make this term minus 2ab term, my minus 2ab term, I want to make it this. So I have a square, 2a. What should be b? So check here very carefully. If I write here 4, it will become 4 into x into 2, so minus 8. And if I write here denominator as 5, so 4 by 5 can be b. So 2ab. So a square minus 2ab, what is missing? Plus 2ab. So what is going to be that? Plus 4 by 5 the whole square. I am adding something extra, right? Then I have to remove that as well. So minus 4 by 5 the whole square. This part is already there, so please keep this as it is. Closing the bracket. I'll repeat so that there is no confusion. Please check here. This part was my requirement to make it as 8x by 5. 4 by 5, 4 into 2 into x becomes 8x. 5 is in the denominator, no problem. Now this is my x square, so a square minus 2ab. So 4 by 5 is my b. So I added 4 by 5 the whole square. Since I am adding something extra, I have to remove that part. So I have taken that out as minus 4 by 5 the whole square. This 4 by 5 was already present here, so I wrote it like this. No new step. So this is one. Next step would look like this. Next step would look like this. So I can rewrite this as 5 times of x minus 4 by 5 the whole square. The whole square, and this will become what? Minus this part. Because what we have done here is, we have clubbed these terms together, right? We have clubbed these terms together in this format. The same thing, no? Okay. Now what will write the next terms as? This is left out, minus 4 by 5. So minus 16 by 25 and plus 4 by 5. Let us simplify this part. So this will become 5 times of x minus 4 by 5 the whole square, x minus 4 by 5 the whole square, and minus 16 by 25 and plus 4 by 25. Let's take LCM. LCM would look like this, 25. So 4 by 25, 5 5s are, so 20 and minus 16. So how much I'm getting this as? This is my px only, right? So my px is coming as 5 times of x minus 4 by 5 the whole square plus 4 by 25. I hope you can see this. Check here. Please check here. So I just rewrote like this. I wrote this over here and this over there, and then I've taken the LCM. I hope you can see that 5 times 5 is 25, so 4 times 5 is 20, minus 16 by 25 is 4 by 25. Okay. Now see carefully here. This is a positive number. Sir, how? How? The square of any number is positive. It can be 0 max to max, but it will not be a negative number. So it is a non-negative number. Writing it correct or saying it correct? Non-negative number. Okay. What about this 4 by 25? Again another positive number. So basically px is always positive. And it has to be, sir, because check out here. Log is not defined for negative values. Log is not defined for negative values. Only for positive values it is defined. Okay. So only on the positive x-axis it exists. So it has to be like that. it has to be what? So because this value 5 is positive, this entire px has to be positive because log is operating on this px, no? So this px has to be positive, okay? All right. Look, I'm giving my time in this question because this question is having lot of concepts. Log is there, graphs is there, all of this is there, then tan inverse part will also come. So that's why taking time so that you can recall all these concepts from here only. Okay, so this part is clear. Px is positive, sir. It means what is the domain for this part? So what I can keep for x? I can keep x as all real values actually, sir. Sir, you said it has to be positive, but I can take this x. No, I'm saying px has to be positive. I'm saying px has to be always positive, and which it is. Px is positive, yes, it's true. But what is the x value I can take? I can take any x value. That's why I said x is all real. X is all real. So what is the domain? What's the domain? Domain is all real. So I can take this part, right? I can take this part. This part is clear. So I can take from here only that answer is A. Answer is A for this particular question, because domain has to be all real, right? Domain has to be all real only. Correct? No? Correct, right? All real only. Px has to be positive, but x value can be any positive, any number. Okay, sir. Let's continue. But anyway, we'll continue and find the range. X has to be all real because I can take any value of x in this, but px will be always positive, right? Because this is a positive, this is non-negative number. This is a positive number. It means all positive. So if I have to write for px the range, I can rewrite this as not equal to sign. This will be what? Infinity, means it can go as to infinity, but it will be always what, sir? Greater than or equal to 4 by 5. Why equal to, sir? Because minimum value will be 4 by 5, no? How 4 by 5? How 4 by 5? Because if I put x as 4 by 5, if I put x as 4 by 5, then this part will be what? 0. So I will get this as 5 times of 0 plus 4 by 25. So this will be nothing but 5 times of 4 by 25, nothing but just 5. Answer is 4 by 5. Answer is 4 by 5, sir. So this is the minimum value. Maximum value is infinity. Apply log on both sides. So log with what? Base 4 by 5. So log 4 by 5 with base 4 by 5. Why that, sir? Because they've given the question. Log with the base 4 by 5. Okay. Less than. So less than sign will become what? Greater than, sir. Because it's, I just said here that if function is what? The function is decreasing in nature. The function is decreasing in nature, right? It means if x1 is greater than x2, then log of x1 will be less than log of x2. Okay, same thing here. So this will be changing the inequality. Inequality less than will become greater than, and this will become log px to the base 4 by 5 and greater than log what? Infinity to base 4 by 5. Correct? What is px? This whole value is my px, bacha. Okay, continue. What will this be? 1 greater than equal to, what is it going to be? Same value. So log of px to the base 4 by 5, and this is going to be what? What is it going to be? Check. Infinity means when x is infinity. What is happening when x is infinity? X is infinity on this side. If I reach infinity, what is the y value reaching? Check here. If I reach x to infinity, keep x to infinity, what is y value? Negative infinity. Y is negative infinity. Y was positive infinity when x was 0. When x is tending to infinity, the y value is going negative infinity. Y value is going negative infinity. So this will look like this. Now I want to find what? Last step. Tan inverse on that. Tan inverse on these values. So I can find tan inverse on both the extremes. Tan inverse on both the extremes, I can find it out. Correct? So if I have to write this again apply the tan inverse. Tan inverse what? Increasing or decreasing function? Increasing function. Tan inverse is increasing function. Don't say you don't know. The graph of tan inverse. Right? What is this band? Pi by 2 and minus pi by 2 for all real numbers. For all real numbers, this is my tan inverse function. Y equals to tan inverse of x, bacha. Okay. So if I apply tan inverse, the inequality will remain same. I can write this as, let me write it over here. So this will be minus infinity less than, okay, I'm just rewriting it, rearranging it. This is greater than, no? I'm writing from less than part. So minus infinity over here, this is less than part, okay? Then this will be same thing, log of px to the base 4 by 5, which is less than what? Which is less than equal to 1. Log is less than 1 and this is less than log. Infinity is less than log and log is less than 1. That's what I've written. I just rearrange this part and I'm going to apply what? Tan inverse on this. I'm going to apply tan inverse on this. Check it out here. I erase this part here. I'll erase some of this here. So I'm applying tan inverse on all of it. So tan inverse of what? Negative infinity, and this is less than what? This is less than tan inverse of log of 4 by with the base 4 by 5 for the px. What is px? I've taken this as px, bacha. I've taken this as my px. Just smaller way to write it down, nothing else. And less than tan inverse of what? Pi by 4. I messed it up. I wrote the answer. Tan inverse of 1. Tan inverse of 1. Check out here. What I've done here. Applied tan inverse on this. I've applied tan inverse on this inequality. On inequality. Tan inverse on this inequality. Forgive me, the question is getting longer. Okay. Now if I do the tan inverse minus infinity, I drew the diagram here. When x is minus infinity, what is the limit? Minus pi by 2. Check here. When x is minus infinity, the value is minus pi by 2. Okay. The value is minus pi by 2. How much is this? Minus pi by 2 less than. This is the same thing. The question, what is it? Fx. This is the fx. Okay. And this is going to be what? Tan inverse of 1 is how much? Is just pi by 4. Pi by 4. So what is my range? Range is nothing but minus pi by 2. They will be kept open and pi by 4 will be kept closed. What was the domain we got? Domain we got as all real. Okay. We got it as all real. Domain we got it as x value. This is my domain, right? Okay. Now, so option is what? A. Look, I could have ended the question over here only, that d equals to r, d equals to r. But what happens now in the question, in the examination, if after this, if they give one more option, if let's say, if this was written like this again, infinity only, then what are you going to do? Which is correct option? This is correct or this is correct? So my goal is to make sure that you understand every aspect of the question. Okay, I can, because since I got the domain as all real, only all of these options, only one place domain is all real, option A. Take the option and move on. Take the option and move on. But knowing this is correct, so I will plan it out. What we did first, we took the question. Okay, in this question we knew the graph. From this we got the domain of the log part. That came as all real, so that was my first part. Then we found out the minimum value of the log, the function that we assumed to be px. The minimum value came as 4 by 5, and highest was infinity. I applied log on it. I got a result in inequality. Applied tan inverse again on it and got a result in another inequality. And my final answer came as minus pi by 2 to pi by 4. Answer is what? A. Answer is A. Okay. I know lengthier, but I hope you understood it. Okay. Chaliye. One more question. Another difficult question. I've taken challenging as well, because not all questions will be easier, no? So it will be using multiple concepts. So that's why this question again. Okay, let's solve this question. Okay, so we'll not try to take that much of time that we took. We'll solve it quickly. Again, let's check it out how many operations are present here. So first is here. I hope this is visible. Cot is there on summation of cot inverse of something, and again summation is present. Okay, again we'll start from the inside. We'll start from here, then go here and go here. Chaliye, let's do it. So first we'll do it over here only, no problem. So first part, I have to solve this part. So if I'm taking only this part, let's say I'm taking only this part. So I'll take with cot. This part I'll leave right now, these two parts. I'll start from here. I'm taking only this much into consideration. Here. Okay, so I'll write only this much. Then again we can keep using it to continue with our solution. So what is it? Cot inverse of 1 plus summation over k1 to n for 2k. This is the question. Now I'm taking 2 out. Cot inverse of 1 plus, I can take 2 out, right? This is the summation Summation symbol is not coming, right? Let's rewrite it. Okay, sir. Okay, sir. This is going to be k, starting from k equal to 1 to n. Do you remember this thing? What is this? 1 to n means 1 is natural number, starting with a natural number. So basically they are asking sum of all natural number till n. We had the formula for this in sequences and series. 1 plus n times of 2 into, right? 2 is there, I missed it, forgive me. 2 into n plus 1 by 2. I can cancel this 2 and 2, right? I get this answer as cot inverse of 1 plus n into n plus 1, correct? N into n plus 1, am I right? Yes, sir. I can rewrite this as, look, okay, I can rewrite this as reciprocal tan inverse of what? 1 upon 1 plus n times of n plus 1. I'll tell you why. Because if you see here, something is forming here. A plus A into B. It's not 1 plus AB, 1 plus AB. So 1 plus n into n plus 1. You'll see how it is useful. So now I've got in terms of tan inverse. This will be tan inverse of. Now can I write using this? If I subtract n plus 1 minus n plus 1 minus n will become again what? 1 only, no? Which is our numerator. 1 only, right? So n plus 1 upon minus n is this thing. Now check here. 1 plus n times of n plus 1. Okay, n plus 1, and close this. We can rewrite this as, this is a formula, no? Tan inverse of A minus tan inverse of B is equal to tan inverse of A minus B upon 1 plus AB. A minus B upon 1 plus AB, right? So if you check here, what is my A value in this case? My A value is n plus 1 and my B value is just n. So I can rewrite this expression as tan inverse of A minus tan inverse of B, which is nothing but what? Tan inverse of n plus 1. Tan inverse of n plus 1. Tan inverse of n plus 1 minus tan inverse of n. Tan inverse of n. Am I right? Correct. Tan A is n plus 1 and like this. So what is this? Now this was only this much what we did. Okay. Now we're going to apply what? Next function on this, which is next operation on this, which is summation. Okay. This part we will apply. Check it out. So over this, if you apply this thing, what we get? Summation over this, tan inverse of n plus 1 minus tan inverse of n bacha, right? Summation is applying where? From n equal to 1 to 23. N equal to 1 to 23. N equal to 1 to 23, right? Okay, sir. Okay, sir. So if you apply this, write for this term first, and then we'll do for that term. So if I write for this term, n will start from 1 to go to 23. So if I put n as 1, it will become 1 plus 1, 2. 1 plus 1, so 2. First term will be what? Tan inverse of 2. Next term will be what? Tan inverse of 3, and so on till last will be 23. So 23 plus 1 will be 24. So tan inverse. So we are writing what here? We are keeping the value of n as 1, 2, 3, 4 till 23. So first term was 1, so 1 plus 1, 2. Second term was 2, so 2 plus 1, and so on till tan inverse of 23 will be 23 plus 1, 24. 24. Okay, sir. 24 is okay, sir. Alright. Now this is for positive part. What about negative part? Same we will do. Minus. What will come here? So we will do this as, first term will be what? Check, the first term would be n as 1. So it will become just tan inverse of 1. Tan inverse of 1. Next will be what? N as 2. So tan inverse of 2. Okay. Next will be what? Same way. Minus tan inverse of 3. Tan inverse of 3. Okay. And last will be what? What will be last term? Minus tan inverse of 23. Tan inverse of 23. Why, sir? Because n is 23 last, and here it says just n is there. Just n is there. Just n is there. Okay. Okay. Continue from here. Continue from here. So this is my one of the step. Both of the terms are same step. Now check, is something getting cancelled? Yes, sir. 2 negative, 2 negative, 3 positive with 3 negative. It keeps going on. Even for 23 also, you'll have here what? Previous term will be 23, right? You'll have a previous term to this will be 23 tan inverse of 23. They'll cancel this also. So what is left on the positive side? Only this will be left. Tan inverse of 24. Tan inverse of 24. Minus, what is left? This part. Minus tan inverse of 1. We just learned this formula. What was going to be? Tan inverse of A minus B. So tan inverse of A minus B. So what is it? What is it? What is it? 24 minus 1. 24 minus 1. 24 minus 1. 24 minus 1 upon 1 plus 24 into 1. Right? Tan inverse of A minus B upon A into B. 1 plus A into B. So tan inverse of 23 by 25. 23 by 25. Okay. So far what we have done? Check here. So far we have solved till this part. We have solved all of this. So we have solved this summation. Now what is left? Cot is left. So apply cot to this. What is this going to be? Apply cot to this. So cot of this part. Tan inverse of 23 by 25. 23 by 25. Okay. Now if I do that, I can again take the reciprocal over here. So it will become what? In the side will take. So it will become cot inverse of 25 by 23. 25 by 23. This becomes cot inverse. Answer is 25 by 23, sir. We had to evaluate for this expression. We got this. First we did what? We solved for this part, this summation. Then we applied cot inverse on that. Then we applied again this summation. Then applied cot on that. Answer was what? What's the answer? 25 by 23. 25 by 23. B. 25 by 23. Okay. Okay. Now last problem of the day. Quickly we'll do. Okay. I hope this is clear. I hope this is clear. First we solve for this part. Looks messy, but okay. First we solve for this part. 2k we applied the sum of all natural numbers. Simplified it. Got in terms of reciprocal of cot to tan. Got this expression. Use the formula. This is again a formula. We use this formula. Simplified this further. And we reached here. Again we took it as the last operator, which is cot. And we again took the reciprocal. 25 by 23 is my final answer. 25 by 23 is my final answer. Okay. Last problem. Alright. Okay. Very good question. Very good question. Sine inverse of A plus sine inverse of B plus sine inverse of C is given as 3 pi by 2. 3 pi by 2. Okay. F of 2 is given as 2. F of 2 is given as 2. And they have also said that f of x plus y. They have said that f of x plus y is equal to fx into fy. F of x plus y is equal to fx into fy for all xy belonging to real numbers. For xy belonging to real numbers. R is there, right? So real numbers. You have to find out this value. You have to find out this big value. A power f2, B power f4, C power f6 minus 3 power 3 multiplied with A power f2 times B power f4 times C power f6 divided by A power f2 plus B power f4 plus C power f6. Looks very confusing, sir. Looks very confusing, sir. Okay. Okay. Might look confusing right now. Let's see something that we can do about this. First step we'll take this thing. Sine inverse of A plus sine inverse of B plus sine inverse of C is given as 3 pi by 2. 3 pi by 2. Now what is the maximum value of sine inverse? The range. The range. If you remember, the range is what? Minus pi by 2 to pi by 2. The range is this. So the maximum value the sine can take or can give out is this angle pi by 2. Can give out is pi by 2. So if I take that value, the pi by 2 for this value, for this also I'll take pi by 2. For this also I'll take pi by 2. Then my sum is coming as 3 pi by 2. Then some sum is coming as 3 pi by 2. It means sine inverse of A, sine inverse of B and sine inverse of C has to be pi by 2 at the same time. It means A and B and C has to be equal. It means A and B and C has to be equal. And equal to what? equal to what? It means A and B and C is equal, and equal to what? 1, because sine inverse of 1 is pi by 2. Sine inverse of 1 is pi by 2. Now check out A power something. Check this part. A power something. I'll write this for you. A power f2 plus B power f4, like this. So it's given like this. Okay, I don't have to write this, so bigger expression. Let me write in the form of 1 only. So 1 power something f2, 1 power f4 plus 1 power f6 minus 3 times of, again 1 power something, 1 power something and C power something. Okay, divided by 1 power something plus 1 power something plus 1 power something. Okay, we can solve that part, not a difficult task. Okay, well, how can we do it? F2 is given as 2. I can write F4 as what? If you ask me, how will write F4, sir? F of x plus y. So I can write F4 as f of 2 plus 2, no? F of 2 plus 2. What is f of 2 plus 2? F2 into F2. They've given it here. F of x plus y is fx into fy. So f of 2 plus 2 will be f2 into f2. What is f2? 2 into 2. How much is that? 4. So f of 4 is 4. Okay, I can keep solving it like this, but is not required. I'll tell you why. Just come here. 1 power anything is what? From here, this step. 1 power anything is 1. 1 power anything is again what? 1. 1 power anything is again what? 1. 1 power anything is 1 only. Okay. Minus 3 times of 1 power anything all this time. So it will remain 1 only. What about this? 1 power anything, so 1. 1 power anything, so 1. 1 power anything, so 1. So what is my final answer? 3 minus 3 by 3. How much is that? 3 minus 1. How much is that? 2. How much is that? 2. Option is A equal to 2. Option is A equal to 2. Okay, I hope you understood this. Okay, this was it, bacha. This was it. We have completed our ITF also. Again, the mocks will come on this session. I hope you enjoyed it. I hope you liked it. I hope I was able to help you out in understanding the concepts of inverse trigonometric functions. Okay. Remember this: to solve any questions on this chapter, you need a very good grasp on domain and range, the graphs, the nature, the properties. Okay, all of this, and this will, I keep telling this, very helpful in other questions also, other concepts also. So make sure that you have practiced enough to solve all these questions. If you have missed it out, pause the videos wherever you have missed it and again solve the questions. Okay, try to solve it after looking at the videos, after looking at the questions. Try to solve all these questions by your side. Okay, again I'll be coming with the next session over here on the same YouTube channel, which is Diksha Karnataka. I hope you are connected with us. Keep giving us your doubts, and I hope I am able to help or make some changes in your studies, in your preparation. All right, so this is it for today's session. I hope you liked it, and see you again in the next session. Take care, keep smiling, keep working really hard, and bye bye for today.